Here you will be given a recommendation on how to work through this program in order to achieve maximum success. What do you associate with Ethernet? You will get the right idea if you think about your PC, smartphone or tablet, which are all able to communicate across one or more networks. Also, a LAN, the so-called local area network, or WAN, the wide area network, is associated with Ethernet. Ethernet, therefore, has something to do with digital networking and communication. But what is Ethernet exactly, especially in the industrial environment, and what actually happens there? We will start with an example from everyday life. You will certainly have sent a parcel to someone once, or received parcels yourself, for example following a purchase online. To do this, you will have used a parcel service that arranged to accept your parcel and deliver it to the required address. This is a simple process, as long as it only concerns the transport of one item. It gets more complicated when several persons or companies want to send parcels to many recipients. The logistical effort rises considerably. You can easily understand that the stages in the process need to be well structured and clearly defined. The processes involved in sending a parcel with a parcel delivery company can be easily compared to those involved in sending data over industrial Ethernet. When devices interact in Ethernet networks, data packets are sent. In the industrial environment, it is important that these are transported safely and quickly from the sender to the recipient. Ethernet is the standard used in the commercial field and is part of our everyday life. Every day, worldwide, more and more computers are connected together and a huge amount of information is exchanged. Think about the emails, for example. Several billion emails are sent every day worldwide. In this case, the information packages contain text, photos, videos, or music files. Due to the wide acceptance and distribution of Ethernet, it is being used increasingly in the industrial environment. Special requirements exist here. The connection systems must be industrially compatible. That is, they must be well shielded and mechanically rugged. In some cases, network components must withstand wide variations in temperature and electromagnetic interference. Harsh environmental conditions also require higher degrees of protection. High plant availability demands special topologies and redundant network structures. Production processes require fast data transfer and short response times. To ensure that communication functions correctly between equipment from different manufacturers, Ethernet was standardized. The Xerox company published the first Ethernet network specification in 1975. In 1980, Ethernet was standardized in 802.3 by the Institute of Electrical and Electronic Engineers, abbreviated to the IEEE. Since then, numerous extensions to the standard have been published. Fast Ethernet was standardized as 802.3U and was introduced in office networks in 1995. The wireless LAN standard 802.11 followed 2 years later. Higher data transmission rates have been possible since 1998, with Gigabit Ethernet 802.3Z, which can also be used in industrial environments. You will find further information in the glossary on the highlighted terms shown in the graphic. Industrial Ethernet provides both horizontal and vertical integration in industrial plants. Vertical communication takes place between the supervisory level, control level, and field level. Horizontal communication takes place, for example, between different subsystems within a level. At the field level, the input signals are received from the sensors and the output signals are transferred to actuators. At the supervisory level, the procedures are visualized for the user and process data is archived. Why is vertical communication across all levels necessary with industrial Ethernet? An integrated network across all levels of automation enables processes and procedures to be optimized and supports a flexible response to changes. At the control level, open-loop and closed-loop control of processes is performed. The signals from the field level are collected and centrally processed. In general, every transfer, whether of goods or data, can be mapped onto the ISO OSI reference model. The model provides a framework which gives the individual steps executed during communication a logical structure. Let us consider the example of sending a parcel. You are planning to send a present to a relative. The intention to send the present corresponds to the application layer in the ISO OSI model. The present is packed into a parcel for transport. The package has a more standardized shape, which will make transport easier. In the ISO OSI model, this represents the presentation layer. You will normally have access to specific control instruments for safeguarding parcel delivery. You are given a receipt. You can insure the parcel separately, track the shipment, and ask the recipient whether they received the present or not. In the ISO OSI model, the transport layer ensures the security of the data packets. In the next step, the post office checks the address. The country and town are then unambiguously defined for delivery. In the ISO OSI model, this corresponds to the network layer in which the IP address of the network node is specified. In the final step, the parcel is sent over the transport route available. In the ISO OSI model, we refer to the physical layer which defines the medium for transmission. Of course, this example only provides a rough explanation of how the model functions. The processes performed in reality are more complex. It should, however, be clear how they interact. After you have brought the parcel to the post office, it is prepared for transport. It is weighed and measured. If your present has to be split into separate parcels, these will be assigned to an overall shipment. In the ISO OSI model, we are now in the session layer. The name of the recipient is then checked. In the ISO OSI model, we refer to the data link layer and the associated MAC address. Layers 1 to 4 are network-based and define all the processes that are required for transporting the parcel from the sender to the recipient. In the example for parcel shipment, the safety mechanisms for tracking the parcel, address, name of recipient and transport routes that the parcel should take are defined here. Layers 5 to 7 are application-oriented and are responsible for data interpretation. In the case of parcel shipment, this concerns the weight, size, and intended use. In the data transmission process, the individual layers are executed twice. Starting from the application layer through to the physical layer, all the data from the sender is prepared for transmission. When this has been completed, transmission to the recipient is performed, the data is received by the recipient and processed from layer 1 to layer 7. The familiar presentation format of the ISO OSI reference model indicates subdivision into 7 layers. These form the basis of communication via multi-vendor systems, protocols, and networks. The model is subdivided into 2 blocks. What substantive points should you have learnt in this chapter? Spend a little time on repeating the main aspects. This chapter explains in